color change. Before it was like a brown type color. Now I think it's like about to die or something.
The brown type color is the copper. Remember, copper has this brownish tinge. The nitrate drops the silver and picks up the copper. As the silver is dropped, there's a color change. That's called a precipitation. The copper goes into solution and changes the water blue.
So we're gonna go to the next one or wait?
Yeah, reaction too.
For that one we need.
Wow. So not only the color changes cause disintegration, you think?
Decomposition.
Yeah, decomposition. That's not really.
Wait, is this a simple replacement reaction?
Actually, it is a single displacement reaction. There is no decomposition.
Good job, y'all.
No, we just put it's changing color for the first reaction, and then we have to keep watching it over the 30 minutes.
I said silver nitrogen is clear. I said.
So do we start working on the other one?
I think so.
Let's
Add some
This?
You gotta change your color.
Yeah, the copper is changing colors.
One question for y'all. What are indicators of a chemical reaction? And what do you see here that shows a chemical reaction?
The color change. Yeah, the color change is the chemical reaction. And
I'm afraid there was some confusion due to how words are used in our everyday lives. Decomposition reactions in chemistry specifically means when one substance breaks down into more than one component. A number of you saw one piece of copper seemingly turning into more than one component. You used the color change to justify your conclusion that it was turning into something. What actually was going on was that, as you can see from the animation, the silver nitrate reacted with the copper and the silver precipitated out. The silver coating on the copper is what gave you your color change. The blue color in the water was due to the newly formed copper. What happened here is that the copper took over for the silver, leaving the silver no other option but to fall out of solution and lay at the bottom of the reaction vessel. There. Let's see, hopefully it works.
This one?
Now when she does that, I'm going to capture the hydrogen gas, right? And then what am I going to do with it? I'm going to set it on fire, and what do we hope is going to happen? And I'll probably pee my pants. Okay, go ahead. More than that. Get some more than that. More, come on. Bunch in there. Come on, get some there. Now we got a little more. Go on. Very good. So we're capturing it. We're producing gas, you agree?
Yes.
And it's not boiling, right? So it's not boiling, so it's different.
Can y'all see? No. Why y'all on the...
So hydrogen gas is lighter than air, so it's going to go up, right? Right?
Can y'all see now?
Yeah, we can see it. Over here.
Try to let the video see it as well. You can move your hand for a second. I got the top. So you see, everybody see the bubbles? Right. So theoretically, that's hydrogen gas. So theoretically, if I add flame to it, what should happen?
It should pop.
And then what am I making? I'm taking energy, I'm taking oxygen from the air, and the hydrogen from there, I'm making water. That's right. So it should release a lot of energy and produce water. That's the theory, right? Mm-hmm. Let's test it. Hold on to it.
Someone hold my hand.
Hold my hand. I'm the one with the fire. It did it, but you couldn't hear it.
Oh, right.
It went pop.
yeah,
A little poppy, yeah. And you can see the water vapor on the inside too.
Oh, that's so cool.
All right, so I should have used maybe a stronger acid, but maybe I can do it again. Let's see. Hold it. It's bubbling like crazy still, so.
Why are you talking?
So I'm capturing the hydrogen gas. If you have to listen carefully, because somebody turn that fan off.
You gotta be quick.
Here we go.
Turn it off.
Just listen. All right, so we know it's flammable, right? All right, next group.
You keeping that?
Yeah, I keep it.
Here the top.
Huh? Thanks. Thank you. Right there is great. Thank you very much for your help.
Now let's go to the copper. Let's see what happened to the copper. Oh, look at that.
What group just brought this acid and base to me? Can somebody come and take this and rinse it out carefully at the table?
Back at it again. Let me see, Johnny.
Remember what we said, this is acid, strong acid, nice and soft with water. Alright, next. Alright, so let's do that acid.
Doing good, doing good. Great job, good job, good job. Let's see.
If you're gonna be scared.
It's just water and acid.
Now when we get in, are you stopping video?
Mr. Mendoza's biology class, first block of the day. Doing great. Good job.
Bring your paper to write it down.
Professional development.
You have a
And
paper.
then we also,
I only have my paper.
most of us have done research. This is a double group, or does everybody want to do their own group? So double group, okay? You want to do your own? You can do your own, but I'm just worried about time. Be careful with this acid. Don't spill it on me.
That's zinc, right?
Yeah, that's it. Okay, that's good. So we got the zinc. It's collecting. So let me see it. Let me show. Get back. So you see how it's producing gas? Yes. And you see how I mix it up? All right, it's releasing a lot of gas, and we theorize that it's hydrogen gas, right? Mm-hmm. So how do we show that it is actually a chemical reaction, not something not a phase change? A color change, but the color. There's not real color change. It's just a lot of bubbles, right? Mm-hmm. It might be a zinky color. It might be a white color. You can say that it's definitely changed color of some sort. If you got a lot of bubbles, how do we know it's hydrogen gas? How are we going to prove this hydrogen gas, not just water turning or acid turning into vapor?
Use the fire, the combustion.
Right. So it's a test, and the test means what? We have to have an if-then statement, right? Yeah. So our concept is people, no talking, please. Our concept is that if it's hydrogen gas that's being released, then, you see how I'm writing that? You guys should be writing it that way too, right? So if it's hydrogen gas being released, then when I expose it to flame, it should explode, right? Now, do I expect a big explosion?
No.
What I expect is a pop, right? I expect a pop. I know, me too. So hold on. Yeah, you hold it. I'm the one holding the flame. Why are you scared? If it explodes. If it explodes, I'll be peeing my pants, so don't worry about it.
You know how to work a lighter.
Hold it the wrong.
I know how to work a lighter.
I know how to work a lighter too, kid. It's hard to flick it when you're using gloves.
His gloves will not.
All right, ready? Here's hoping.
Okay.
So you see it producing. You see the water you made?
So it produced.
It produced water, right?
Drink it.
Hydrogen. Don't do that. You could if everything was sanitary. It's not sanitary. We don't do that. What color is copper nitrate? It's a blue, right? So copper nitrate's a blue. Who has the liquid or the container? Where's your flask?
Oh, that's what that's water.
No, now wait. Now we need this. You know, and you need zinc, right?
That's a flask.
See, now we could use this. We don't need a beaker. The reason we need a beaker is because this is too big to fit into your flask, right? Or your reaction vessel. You guys are lucky to get brand new copper nitrate.
Do it ever expire over time?
Good question. Not even teachers get that. Yes, they do. It does expire over time.
So what happens when it expires? Like
It doesn't react very well, or it reacts in a way you can't predict. You need to go in that direction. You need to stay away from my acid. All right, so you need to take some of this. You're gonna get pause that for a second.
So it, okay, as smoke
wait, hold on. We on 3.
Right. So we put this in there.
Copper nitrate is blue. Or do you put that in there?
What? Do we?
No.
Doesn't matter.
We pour it in the test tube. We pour it into the test tube. Hold on, don't do it yet.
In physical. Keep your face away from it, just in case.
Away from the
Yes. Away from people. Let's see. Back some. You don't want to be too close.
No, I feel smart.
So what is it supposed to do?
Oh, you gotta watch and see.
Do we need
Shake
more?
it. Shake it.
Somebody took my Captain Copper nitrate home.
Do we need more?
Uh-oh.
Who has an extra cap at their table?
Do we got an extra cap?
These two.
I think we need more zinc. We'll get some more zinc. Or some more.
Wait.
Oh.
So this third one is copper nitrate.
What is it supposed to do?
Make sure it don't drip.
It's some inside.
Don't touch it. Don't touch it.
I think we need more zinc. Go get some more.
Do you think we need more? Or is something supposed to happen all the time?
You said it's doing what?
It's turning black. The color changing.
Go from silver to black.
We're changing colors.
Did yours turn black? Oh, you didn't need it as much as you thought you did.
So here is the copper with the silver nitrate reacting 2 times faster than you would see in the lab. Now this is a close-up. It's using a dissection microscope, and you're going to see the silver forming along the edges, dropping out of solution. And you see that it does turn kind of a blackish color because of the silver layering on top of the copper. But see how the silver forms? It's a solid, and as it falls out of solution. Remember, solution means that the parts, this material is suspended in water. As you saw in the animation that I made, the water molecules move in and around the particles of the silver nitrate or copper nitrate, depending what's going on. As the silver falls out, the copper takes its place and becomes copper nitrate. That's why there's a blue color.